Just a quick review over the Fick principle and its application to VO2. And remember, VO2 is the rate at which oxygen is consumed in the body. Okay, and with using the Fick principle, we use cardiac output times the arterial minus the venous oxygen content. Okay, so the equation reads as VO2 is equal to Q times the AVO2 difference. We'll start with Q, just a quick breakdown. It's a product of heart rate in beats per minute times stroke volume, which is the amount of blood that's ejected with each heart contraction. Remember, you can figure this number by the end diastolic volume minus the end systolic volume of the left ventricle. So if you look at how much blood was in that left ventricle right before it contracted, how much was left at the end of its contraction, that difference was what's ejected. Take that as your stroke volume. Take your stroke volume times your heart rate in beats per minute, and you get some flow of blood in terms of over some unit of time, which normally we're looking at liters a minute in Q. Then your next variables are this A and VO2 difference. A is quite literally just the oxygen content of the blood coming out of the left side of the heart on the arterial side, traveling out towards the systems. So this is blood that's just come through the lungs, it's been oxygenated, and it's about to go out towards the system to deliver nutrients. The V is just the oxygen content of the venous side of the blood as the blood is returning back to the heart. So it's already made it through the systems, it's been kind of recollected and returned through the veins back to the heart. And we find the difference between these two to be the oxygen that's been delivered to the tissues. Okay, and so the tissues are now uptaking this oxygen that the arteries brought to them. The remainder of the blood with the remainder of the oxygen goes back into the venous side and goes back. And remember, the tissues use O2 in the electron transport chain. Remember, oxygen is that final acceptor of the electrons in the electron transport chain. And so all these variables work together to help us solve for VO2. Now, using algebra, if you had 3 of these numbers, you could end up solving for any one of them. Remember, cardiac output changes with the onset of exercise or the termination of exercise. So does the AVO2 difference. So does VO2 needed. These things change with training and detraining. And so it's important to keep these principles in mind going forward. Now, we'll go over later some of the mechanisms of drive changes in these various variables. But for now, get a good grasp on the Fick principle and understand how it applies to VO2 and changes in the body.